All right, let's get right into it. We're tackling a massive hardware decision for anyone who's serious about running AI locally. The brand new, super efficient RTX 5080 versus the reigning champ, the brute force RTX 4090. You know, this isn't just about picking an upgrade. It's really about making a bet on where AI is headed. So you're at a crossroads, right? On one side, you've got the proven powerhouse, a card that's just dominated the AI benchmarks for what feels like forever. And on the other, you have the new challenger, built on a completely new architecture that promises a smarter, way more efficient kind of performance. Which one is actually right for you?
Let's frame this showdown, okay? The RTX 4090, that's the VRAM king. It is packing a ridiculous amount of memory, which is perfect if you're working with massive models. Then there's the RTX 5080, the efficiency expert. It's the sleek, new contender that's all about next-gen performance per watt. So we're talking raw power versus smart precision. Let's dive in.
To really get what's going on here, we have to look under the hood, deeper than just the model numbers. We need to check out the engine inside, the architecture. The 5080 is built on the new Blackwell architecture, while the 4090 is running on the last generation, Ada Lovelace. And hey, don't just take my word for it. NVIDIA's own CEO, Jensen Huang, laid it out perfectly. He said Blackwell is the engine of AI. I mean, that tells you everything right there. It signals this major shift in focus, baking these AI-specific upgrades right into the chip itself. At the very heart of this AI engine are the tensor cores. The easiest way to think about them is like they're the specialized AI muscles of the GPU. They are designed to do one thing and one thing only. Just crush the complex matrix math that powers literally everything from Stable Diffusion to the big language models. Now this is where it gets really interesting. The 5080's new 5th-gen tensor cores totally changed the game. They bring in support for these new smaller data formats like FP8 and, get this, FP4, which is exclusive to this card. Think of it like this. If AI data was a conversation, the 4090 speaks in these full, complex sentences. But the 5080 with FP8 and FP4 can use this super efficient shorthand that the new AI models are just starting to understand. It means it can get the same ideas across faster and with way less effort. And that's a trick the 4090 just can't do. Okay, so that's all the tech talk. But how does this new stuff actually perform in the real world? Let's get to the numbers. First up, the RTX 5080. It's putting up a huge number, 1,801 AI TOPS. That stands for tera operations per second, and it's a raw measurement of its potential AI horsepower. By comparison, the RTX 4090 comes in at 1,321 TOPS. So right away, you can see that generational leap in raw power. But, and you knew there was a but coming, right? Raw TOPS don't always win the race. Just take a look at this benchmark for Stable Diffusion XL. Even with a lower top score, the RTX 4090 is actually faster. It generates an image in 7.5 seconds, while the 5080 takes 8.8. So what's happening here? Well, this particular task is a memory hog, and the 4090's massive VRAM gives it a huge brute force advantage. And here's the twist. While the 4090 won that last round, the 5080 was doing its job way more efficiently. We're talking about 20% more performance for every single watt of electricity it sips. That means less heat, a lower power bill, and it's just plain easier to build a system around. And that right there, that brings us to the absolute core of this whole decision. What are you chasing? Is it the most VRAM you can possibly get for these gigantic models? Or do you need that smarter, power-efficient performance that's built for the future? This spec sheet just lays it all out, plain and simple. Just look at the two key battlegrounds here. For memory, the 4090 is the undisputed king with a massive 24 gigs. But then, look at the power consumption. The 5080 is way more disciplined at 360 watts, while the 4090 is an absolute power-hungry beast at 450 watts. And that, my friends, is the price you pay for all that extra memory. So, the case for the RTX 4090, the VRAM king, is pretty straightforward. If your day-to-day work involves training models on gigantic datasets or running large language models that need every single last gigabyte of memory you can throw at them, then its 24 gigs is pretty much non-negotiable. It's still an absolute powerhouse for any job that hits that VRAM wall. But then you've got the case for the RTX 5080, the efficiency expert, and it's just as compelling. Its lower power draw means it's so much easier to cool, and it'll fit in more PC cases without you needing a mini nuclear reactor for a power supply. Its support for future tech and that awesome performance per watt make it the smarter, more forward-looking choice for AI inference. The day-to-day work of actually using AI to generate images, text, or code. Okay, we've laid out all the pieces of the puzzle, we've seen the tech, we've looked at the benchmarks, and we understand the trade-offs. Now let's put it all together and get you a final verdict that actually works for you. The big question remains, which one of these incredible GPUs actually belongs in your machine? Let's break this down into a super simple three-step plan. First, be real with yourself about what you're going to be doing. Are you constantly hitting memory limits with huge models, or are you running leaner tasks where speed and efficiency matter more? Second, what's the reality of your setup? Can your power supply and your case fans actually handle a 450-watt monster? And finally, once you've got those answers, you can pick your champion with confidence.
So here's the bottom line. It really is this simple. The RTX 4090 is your champion if you need maximum VRAM, period, and you have the beefy setup to power and cool that beast. The RTX 5080 is your champion if you care more about efficiency, you want that future-proof tech like FP4, and you're mostly running those day-to-day inference tasks.
And that leaves us with one last really fascinating question to think about. As these AI models get smarter and more optimized, and the hardware gets more specialized, what's going to matter more in the long run? Just having more raw memory, or having smarter, more intelligent efficiency? Now, if you really want to nerd out and dive even deeper into all the benchmarks and specs, you can read the full in-depth comparison at the link you see here. It's also down in the description. Thanks for joining me for this breakdown.